Okay, now for grade 12, pattern, sequence, and series. All right. So in grade 10, you learned about your linear terms, and the formula was Tn equals to A plus n minus 1 times D. We learned that Tn was the general term, n was the position where the term is, A was the first term. So if your terms were T1, T2, and T3, so your A will be T1, the very first term. All right. And then you will see here on this sequence, we have 2, 3, 6, and 11. A is that 2 there, the first term. And then D is your constant difference. Okay. And the way to determine D is that you would take your term 2 minus term 1. If that is equals to your term 3 minus term 2, then you know you have your constant difference. Okay, that is what you learned in grade 10. So when you got to grade 11, then quadratic equations patterns were then introduced. The general term equation was Tn is equals to an squared plus bn plus c. So with this one, there wasn't a constant difference, but rather a second constant difference. Okay, so let's see what are we talking about when we say second constant difference. Okay, so with a sequence like this 2, 3, 6, 11, 3 minus 2 is 1, 6 minus 3 is 3. So there is no constant difference the first time around. So when we go now and do the same thing with the difference that we just did, you will see that 3 minus 1 is a 2, and then 5 minus 3 is a 2. Then we have a constant difference, but for the second time around. Hence the term second constant difference. And then the way in which we find the value of A, B, and C was determined by these formulas. Your 2A would be equals to the second constant difference, then 3B, 3A plus B would be equals to 1, calculated there, and then A plus B plus C will be equals to your first term of the sequence. So that's how far we went in grade 11. So now grade 12. Grade 12, we have sequence and series. So it's a continuation. Whatever you learn from grade 10, 11 is not to be forgotten. Sequence and series is a continuation of what we did in 10 and 11. All right. So let's start with sequence. There are two types of sequence. We have an arithmetic sequence. We have a geometric sequence. Your arithmetic sequence is exactly as your linear pattern that you learned in grade 10. And we do find the constant difference the same way. Okay. And then for the geometric sequence, this one now, we do not have a constant difference, but rather we have what we call a constant ratio. A constant ratio depicted by the letter R. So how do we find this constant ratio? You take your second term, you divide it by the first term, and then you take your third term and you divide it by the second term. If they are equal, then you have your constant ratio. So if your terms are T1, T2, and T3, T2 divided by T1 being equals to T3 divided by T2 makes it a constant ratio. So unlike with arithmetic sequence, when you go to the next term, you have to add a certain constant number. With geometric, to get to the next term, you would have to multiply by a certain constant difference. All right, and then what is a series? A series then is a sum of the terms of a sequence. A series is a sum of the terms of a sequence. If your sequence is T1, T2, and T3, add them together, then we call that a series. So when we have T1 plus T2 plus T3 plus up to the nth term, and this can be represented what we call a sigma notation. So a sigma is this sum symbol here. So with TK, so what this means is that sum these things, the TK starting from when K is equals to 1 up to N. So you will see that we start when K equals to 1, then after 1 comes 2, after 2 comes 3, that plus dot 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 plus up to the nth term. Okay, you will see when we do exercises how they ask questions of the sigma notation. All right, so we have two equations, two formulas of the series, geometric series, or geometric series and arithmetic series. Okay, if you are looking for the sum of the arithmetic sequence, that is the arithmetic series, the formula would be Sn is equals to n over 2 into 2a plus n minus 1 into d. You'll see that it looks similar with your arithmetic sequence over there. Or if you know the last term, you can use this formula, which is n over 2 into a plus l. This l is your last term. Okay. If we knew here, maybe let's say there was a last term that was given to be 35 after 11 there, then that 35 would be your L. All right. So whether you choose to use this formula or that one, it wouldn't make a difference. We would get the same answer. Okay. So it's just that with A plus L, it's kind of a shortcut if you are given the last term, of course. If you don't have the last term, then you are forced to use that first formula. How about the geometric series formula? Remember geometric series, what is it? It is the sum of terms of the geometric sequence. Okay, with that one, then we have Sn is equals to a into r to the power of n minus 1 divided by r minus 1. Or you can say a Sn is equals to a into 1 minus Rn divided by 1 minus r. Whether you use this formula or that one, up to you. You decide. But notice that r should never be equals to minus 1. Because if your r equals to minus 1, you're going to have 1 minus 1, creating a division by 0, and we know that's an error in mathematics. And then the last formula to learn is that what we call an infinite series. All right. It's S infinity is equals to the first term A divided by 1 minus R. All right. So this series formula can help us also to determine if a pattern is convergent or divergent. A pattern is convergent if your R is between minus 1 and 1. If you find R, let's say, and then after calculating your R, you find it to be maybe 0.1. That 0.1 is between minus 1 and 1, then we say it's convergent. So that means infinite series in that instance does exist. An infinite series only exists if your pattern is convergent. But if your R is less than minus 1 and R is greater than positive 1, then this series is known to be divergent. Instead of convergent, then it's divergent. So if your pattern is divergent, then the infinite series does not exist. An infinite series does not exist for a divergent pattern, but does exist for a convergent sequence or a pattern. All right, that is all for the theory. In the next video, we're going to learn how to prove your the formulas for the arithmetic series as well as the geometric series.